Okay, so the second part of that problem, which is here, part B, deals with case 2, so the other case we might have to deal with, which is where the covariance matrix is not a scalar times the identity matrix. So we're going to do the same kind of thing again as part 1, but we have to use a different formula basically. And there's maybe like 1 or 1.5 things that are worth noting about it, so let's go through it. So if it's case 2, so first, in order to identify that it's case 2, all you need to see is that the covariance matrix is not some scalar multiple of the identity matrix. So you're given that this is the covariance matrix, 1, 0, 0, 2. So it is diagonal, but because you have different values in the non-zero elements, then you know that it's not a scalar multiple of the identity matrix. And also the covariance matrix has to be same for all the classes, but it is in this case, so that's all right. So from the magic of television, here's the inverse of the covariance matrix. You can find that with your calculator or by hand if you're really into that kind of thing. This is the regular formula for it. It's derived from, I think, a Gaussian distribution. They use the fact that like if you apply some function to the discriminant function, you still get something with similar traits or something. So I don't think we're going to need to know how to derive this or anything like that. But this is what it looks like, and it's a mouthful, but there are ways we can simplify this. So first of all, in order to understand how to simplify this equation, we need to remember what we're doing with the equation, right? So what we're doing ultimately is we're going to see what's bigger, g1 of x or g2 of x. And one way to do that is to just subtract them and see what the answer is, right? So since we're comparing them like this, or like subtracting them from each other in a way, then we can take a look to see if there are any terms here that are constant. Because if there are any constant terms here, it won't make a difference. I mean, they're going to be cancelled out when taking the difference of g1 of x and g2 of x. So this d over 2, d is the number of dimensions, like how many features you have. This term here, which is the ln of 2 pi, that's a constant, so we can cross it out. This here, the ln of the covariance matrix, if the covariance matrix is the same for all classes, then we can cross that out too. This we're going to leave alone. This last part though, ln of the probability of it being class I. So in the question, at the start of the question, it describes that each state of nature is equiprobable. So because there's two states, so that means that the probability of all the classes is equal, which means that it's a constant for all the classes, which means you can cross that out too. So this becomes 0, this becomes 0, this becomes 0. So then all you're left with is this part. This part you do have to calculate. So again, we get to cross out those terms because we're comparing them, and these terms are all constant. So in the context of comparison, they don't mean anything, and we can toss them out. So when actually doing this, we'll try and classify sample 1, which is the same as the first thing, and the distributions and everything are the same too. So the only thing to really note is the order of the multiplication of this. So at first, I tried to just bring this like covariance matrix out to the front so that it would look closer, it would look more similar to the case 1 formula, but it doesn't work like that. It needs to be multiplied in a certain order. So first you got to multiply the first two matrix terms. So this is the This minus 1 means the inverse of this first, right? So let's call this, like, I don't know, alpha. And then you got to do alpha times the third term, right? So again, step 1 here is multiplying these two together first. Then step 2 is multiplying the product of that together with the last term. And that's all there is to it. Really, everything else is like the same to the last one. There's no tricks or anything that I found. You would calculate the value of g1 of x1 and g2 of x1, and whichever one has the bigger value or the more positive value is what you should classify it as.